Oh, let me erase this. Okay. This video is in response to a question from someone who has already taken the first version of the periodic trends test and had a couple of questions that they needed clarified before they go at the second version. So the first type of question was the one where you have ionization energies and you're going to identify where it is on the periodic table. All right, so we're going to look at, well, actually, let's look at these, because ionization energies, right? We're taking the first ionization energy is the energy to get the outermost. Second ionization energy, the energy to get the next one in. Third ionization energy, the energy to get the next one in. All right, so let's go over here. Let's get a periodic table. All right, and let's just look at, all right, so if I have sodium, right, is 1s2, 2s2, 2p6, 3s1. And then magnesium is 1s2, 2s2, 2p6, 3s2. And aluminum is 1s2, 2s2, 2p6, 3s2, 3p1. And then silicon, 1s2, 2s2, 2p6, 3s2, 3p2. All right, so let's think about this. So in looking at, all right, say, and we did, how many did they give us on that question? Hang on, let me close down some of these documents. Sorry about that. Okay, too many tabs. All right, we have 5. All right, so let's just look at that, what that means. All right, so for sodium, so this would be the first ionization energy, would be that 3s. And then the rest, I2 through I5, right, would be 2p electrons. So in sodium, we would expect, because the second energy level is much closer to the nucleus. So for sodium, we would expect to see a large increase in when we go to try to get that second electron, because the first electron is out in the third energy level, so easy to get, but then that second one is going to be a lot harder to get because it's way closer to the nucleus. Whereas if we look at for magnesium, right here, I1 and I2 are 3s electrons, which means I3 through I5, those are going to be 2p's, much closer to the nucleus. So for magnesium, we would expect to see a little bit of an increase between I1 and I2, but then I3 should have a large increase in the amount of energy that it takes, because again, it's in the second energy level, much closer. All right, so keep going here. Here, this one is I1. This would be I2 and I3, right? Okay, a little bit closer, not a huge, but then bam, as Emerald would say, I4 and I5, right? Big jump there. Okay, so we would see a little bit of an increase, I1, I2, I3, but then I4 is going to take a significant amount more. All right, and just to drive the point home, I1 and I2 are these 3Ps. This one would be I3 and I4, and then I5. So here, gradual increase, I1, I2, I3, I4, and then big jump, I5. All right, so now let's see what we can do with that information. So here, where do we get our big jump? So it's about, looks like maybe times 3 there. Here to here, that's not even doubled. So it's like increases by about 1/2. Here, it goes up about almost 4 times, maybe a little more than that. And this one, again, it's not even double. So we'll just say less than times 2. All right, so here, it's easy to get. We get a little bit of an increase, I1, I2, I3, right? So I1, I2, I3, and then I4 is the one that is in that second energy level, because that's where we got that biggest jump. So if we go back to our things here, so we want to see where I4 is on the closest. So that would be this one, aluminum, on there. All right, let's take a look. I think I put another one of these in there. So let's take a look at here. All right, so this is in period 2. All right, so period 2, let me go back and clear out. All right, and so for this one, I'm just going to use, well, oh wait, we didn't answer that other question. Hang on. All right, so now, how many valence electrons are present? Well, all of these that are easy to get, those represent your valence electrons. And if we go back and look, right, at aluminum, the valence electrons are the ones that are in that outermost energy level. So 2 plus 1, it has 3, right? And again, how do we know that? The valence electrons are the easy ones to get. 1, 2, 3. Then we get the big jump. So 3 is the number of valence electrons. All right, so now let's look and see how we can do that without having to write out the electron configurations. So looking here, let's erase. Give me an eraser here. All right. Okay. All right. Okay, so now these are the second period. So we're looking at these right here. Okay, and remember, to find valence electrons, you count the S's and P's in the row that it's in. Okay, so for example, let's just take another. So right, so lithium would just have 1. So if we do valence electrons, so lithium would just have 1. That one right there. Okay, beryllium has 1, 1, 2. Okay. Boron has 1, 2, 3. Carbon, right, has 1, 2, 3, 4, right? So you get the gist of that. Okay, so we can use the periodic table to figure out, if we use the ionization energies to figure out how many valence electrons, so we're kind of working backwards, like from what we did a minute ago, then we can use the periodic table to find out what the element it is. All right, so let's take that approach there. Oops, I did over my highlights. Okay. All right, so go back. All right, so looking at here, right, we got here to here, it's maybe almost doubled. Here to here, that's maybe 2.5, a little bit more. Here to here, that's maybe 1.5. But then here to here, boom, there's the largest increase right there. That's like about 4 times. Okay, so all of the electrons before that one that took tons of energy are valence. So for this one, I have 1, 2, 3, 4 valence electrons. So let's go back to our periodic table. And 1, 2, 3, 4 valence electrons. That element is, I'm writing with highlighter, carbon, right? Go back to periodic table. 4 valence electrons means it's carbon. So there's kind of two approaches that you can use on those types of questions. I'm going to come back and do a separate video on the atomic radius question, just so they're not